The producers and distributors of Tech AV training material welcome you to the fourth module in a series entitled Programmable Logic Controllers. In this module, we shall be discussing the PLC as an information processor, and you will learn how it handles information by checking and recording the state of each input location, deciding the state of each output, and then activating the outputs. Remember that your workbook contains the necessary information to help you understand the subject matter, so ensure that you read the resource notes before viewing each section of the video program. Let's begin this session with a brief review of the key points we discussed in Module 3 of this series. Firstly, we explained how the PLC communicates with the external devices through its input and output interface circuitry. Then we discussed the symbols, notation and I/O addressing required when using a ladder logic diagram to display the user program. Finally, we explained how a PLC uses the on-off voltage signal from an input device to turn an output on or off, depending on whether the PLC has been programmed to examine the input location for an on or an off voltage signal. Now let's begin Module 4 and find out how the PLC processes information. As we know, the PLC has no moving parts, but several times every second it examines each input location, reading and recording the state of the inputs. Then, following the user program, which we represent as a ladder logic diagram, it decides what the state of each output should be, and then it activates the outputs. At the heart of the PLC, we find the Central Processing Unit, or CPU. The CPU consists of three main parts, namely the processor, which carries out the instructions and operations necessary to keep the system running, the memory section, which contains the information or data that the processor needs to operate, and the power supply, which provides the required low-tension DC power from the incoming AC supply. This is what the processor does. With precise regularity, it checks the state of the inputs, solves the user program, and sets the state of the outputs. It is the thinking and calculating part of the controller. When we enter our user program into the PLC, it is the processor which carries out the instructions. This operating cycle happens continuously many times a second by a process called scan. Think of it like an endless loop, and every time a loop or scan cycle is completed, the scanning process begins all over again. Now let's look at the memory section, whose function it is to store instructions and data. In a typical computer system, we find two kinds of memory, namely system memory, or ROM, and application memory, or RAM. The processor is a very fast and efficient operator, but it remains asleep, as it were, until it receives the necessary instructions to tell it how to process information and where to find the data it needs to work with. This is the function of the system memory. It contains all the details that the processor needs to get going and what to do with the information it is being fed from the user program and the I/Os. Now let's look at the application memory, or random access memory, simply called RAM. Information is stored in RAM concerning the input, output, and logic processing that takes place when the PLC executes the ladder logic program. Unlike the ROM, or read-only memory, which is only able to be read by the processor, the RAM, or random access memory, can be either read from or written to by the processor. Now let's see how the memory functions. It is usually found in an integrated circuit or microchip, where thousands of tiny electronic devices and circuits are arranged to create a matrix of memory cells. We can think of each memory cell as a miniature two-state switch, which can be turned on or off by an external source. And like the contacts on a latching relay, the switch remembers its current state until it is instructed to change to the opposite state. The system memory, or ROM, arranges each tiny switch into units of typically 8 or 16 switches each, and we call these groups registers. Each of these registers has a specific address, so that the processor knows where to find them, and each register contains a particular piece of information that the processor can use during a scan cycle. The information contained in a particular register depends on the state of the switches, and different combinations of on and off switches mean different things to the processor. For example, when an on or off state at an input address location must be remembered, or when a number is being stored, or when an output address location must be turned on or off. The switches are in fact binary digits or bits which have a value of either 0 or 1, and a group of bits is called a word, which is the fundamental unit of information used in almost all computers. After the break, we'll return to discuss internal logic devices.